I'm Hilary Smith. I'm one of the solution engineers working for Ansem, and I'm very excited to introduce you to our company. Ansem is a Swiss enterprise that has built a solid reputation for excellence and reliability. Our Swiss heritage instills in us relentless pursuit of perfection and a meticulous attention to detail, ensuring that we consistently exceed expectations. Our team is composed of a diverse group of individuals, each bringing unique expertise from various backgrounds. Stora Enso is seeking innovations to transform the efficiency of its power plants, specifically focusing on optimizing steam and electricity production. We propose to achieve this by making use of big data analytics to make optimal decisions, specifically creating an interplay between a predictive spot price model using the SARIMA model and advanced process monitoring, making use of control charts. In the current operating system, there is constant communication between the DCS and the plant. However, this is a closed system. External to this, there is the spot price market, where information is received by a middleman and his insight guides the plant in its operation. Ansem proposes to break this closed loop system and provide continuous decision making to the plant to reduce costs, increase efficiency, and reduce your environmental impact. To do this, we firstly need to develop a predictive spot price model. A SARIMA model was used to predict the spot prices. This type of model is very advantageous as it does not require any model inputs as it is autoregressive, meaning that it regresses on its past values and updates itself based on the errors made in its past prediction. In the ideal scenario, the firing rate is directly proportional to the spot price prediction. High spot prices leads to high firing and vice versa. The spot price is seasonal, and thus this firing profile will lead to boiler instability and ultimately plant instability. To solve the instability problem arising, we need to incorporate the predictions from the model into advanced process monitoring to determine the optimal firing rate, considering stability in the boiler. Control charts are graphical tools used in quality control to monitor whether a process is stable. It plots the process parameter over time and you compare it to these two static control limits. And once the process parameter deviates outside of the region bounded by the limits, you know your process is out of control. Ansem developed new control charts which plots the moving average of the process with dynamic control limits. This offers greater sensitivity to changes in the process parameter and ensures greater online time, as your chart would not signal unnecessarily. These charts only monitor one parameter over time, and so we need to develop new charts which monitors entire processes. In order to not get lost in dimensions, we will only focus on two variables for now. A bivariate distribution is in 3 dimensions and looks like a mound or a peak, indicating areas where the combination of the two variables are more likely to occur. To construct a confidence ellipse from this distribution, you project the 3-dimensional data onto a 2-dimensional plane. The confidence ellipse is drawn to encompass a certain percentage of the data points. The shape and orientation of the ellipse reflect the covariance between the two variables. Points outside of the ellipse is regarded as outliers, that is, they are out of control points. Now, to determine whether the points are inside or outside of the ellipse, we calculate the statistical distance between the centroid of the ellipse and the observed data points. From distribution theory, we know that the statistical distance follows an F distribution scaled by the number of points and the parameters you are analyzing. Therefore, since the F distribution is univariate, we compare the calculated statistical distance to a single value to determine whether the point is out of control. Now, let us apply this theory. When you look at the boiler as a whole, we will track all of its important parameters. For instance, the steam header stability, the firing rate, the liquor availability, your furnace conditions, and many other. All of this will go into your multivariate control chart, and you will get a single value which you will compare to a single limit, and then you will know if you have a stable boiler or not. When it plots above your control line, you are out of control and corrective action needs to be taken. Finally, how will these two models interact with one another? The points within the red bands are analyzed for the sake of brevity. As mentioned previously, the ideal firing rate will be directly proportional to the predicted spot prices. However, using the information from the control chart, we can get bands for the firing range, which will not cause any process upsets. And as can be seen, the ideal firing rate will cause instability for the majority of time. So, by filtering the ideal firing rate, we can get the optimal firing rate, which would ensure the electricity balance is optimal and the boiler remains stable by taking into account your spot price predictions. Now, how will our solution look? Our solution will live in an ANSYM virtual machine connected to Nord Pool through an API. It will take in all of your boiler conditions and it will provide guidance based on your boiler operation and your power plant availability. We can also extend our solution so that it includes all of your mill-wide conditions by taking into account all of your plant's conditions, and we can align that with company strategic overviews to give guidance based on these. Finally, what will your value be? The proposed value will be an optimal electricity balance, which focuses on steam and electricity production. Another major benefit is that we will ensure that the boiler is running stable, so to minimize machine downtime and not cause unnecessarily boiler swings. We will also seamlessly integrate into existing Stora digitization projects. Thank you for your time. We are excited on embarking on this journey together.